Good afternoon. Thanks for having me back. So I wanted to take this opportunity to share with you a few examples of the benefits and savings that actual consumers have experienced through AMI and smart grid deployments. And just a quick word about me first. So I've been with the company Silver Spring for 12 years. Actually started out running our software group back when it was all of, I think, 4 or 5 people. Helped launched our cloud service business, got involved in managing our delivery. I've been involved in probably, at this point, 3 or 4 dozen deliveries with our customers around the world. Moved back into engineering and then have recently been moved into the CTO role. So I like to joke that all the successes, I give credit to my team, and all the failures, I was probably involved in some way, and hopefully I helped clean it all up. So as we think about AMI and smart grid projects, typically there's a few different constituencies or groups of beneficiaries. We spend a lot of time talking about the utilities and the benefits that they receive that should be passed on to the consumers. There's obviously the environmental benefits and hopefully positive impact that can occur. But ultimately, it's really all about the customers and the end consumers. And what the case studies I'm going to share with you now are all coming directly from actual deployments. All the information is publicly available. So if you want to go through and check it out, happy to share that information with you, share with you all the references. I'll also point out that in every single case that I'm aware of, but certainly all the cases that we cover here, the actual benefits that were realized exceeded what were planned when the initial business case for that deployment was filed with the regulatory agency. So we've got a great track record of actually over-delivering on the commitments. And typically that's being over-delivered in a couple of ways. Typically the projects proceed faster than originally expected, because as you get into it, you realize it's actually not as hard as perhaps first thought. And secondly, the magnitude of the benefits tend to be larger, as typically the efficiencies are made feasible more rapidly, and there's tend to be broader customer adoption than had originally been planned. So let's go into some of the details. So first off, near and dear to everyone is the notion of lower electricity bills. So this has been realized at ComEd, so that's the utility for the Chicago area. So they are reporting, and they actually have a responsibility to the legislature of the state every year to produce a report that summarizes their progress on their smart grid program. So they are reporting over $100 million annually in savings that's directly passed on to their consumers in the form of lower delivery charges for electricity to those consumers. So let's do the math. They've got about 4 million customers, so 100 million divided by 4, so that's $25 each year that's going directly back in, on average, into the pockets of their customers. And where is this coming from? It's really all operational efficiencies. Able to not have to manually read meters, not manually go search for outages, not have to deal with faulty data coming in from their system, have that all be highly accurate, highly secure, highly reliable. A variety of other benefits, but those are some of the main ones. And I'd say ComEd's experience is not at all atypical. We've seen very similar experiences with most of our other customers who focused on AMI deployments. I've heard Lorraine talk this morning about some of the recent PUC directives, and I think they're really focused on flexibility is one key theme. So flexibility around new types of storage, flexibility around new types of distributed generation. But this is another type of flexibility, which is directly making it easier for customers to get the service that they need. So this is a case study from Sacramento Municipal. They're a utility in California. It's actually the state capital of California, with about 800,000 customers. Sorry, excuse me, 650,000 customers. And what they were able to offer was the ability to extend the time for a customer to pay bill, and then to eliminate the need that I'm sure all of us have probably experienced at some point in our life of waiting by the house between typically a 2 or 4 hour window for a utility representative to show up and turn on the power. Instead, they can process the payment from the customer and then turn on the power remotely. As you see, a typical example of that is actually 17 minutes. And that 17 minutes there even includes the initial disconnect, the customer realizing their power was actually disconnected due to lack of payment, calling in, paying the bill, and then having that power reconnected. So this is typically a benefit that's not quantified in any way in the business case for a smart grid deployment, because how does one actually quantify the value to the end customer? Speaking as an end customer, I value my time a great deal, and I suspect all of the utilities customers do as well. So being able to have my power turned back on, and I can cite another example from a coworker. They went on a multi-month trip to Europe. They forgot to pay their electrical bill. The wife actually preceded the husband home from their trip, and so she comes home late in the afternoon, exhausted after a 10-hour flight, and discovered that all the power is off in their apartment in San Francisco. So rather than having to go find a hotel and sleep somewhere that night, able to call the utility, pay the bill, have the power turned right back on within minutes. So real-world example, and I'm sure given the sort of customers we have here in Hawaii, that sort of use case would not be atypical. Another clear example is around avoiding power outages. So this figure is again from ComEd in Chicago. So cumulatively since 2012, they've had over 6 million avoided customer power interruptions. So that's enormous. You think about the hassle that a customer goes through whenever their power is turned off, right? They get to go reboot their computer. They need to go perhaps reset the clocks everywhere in the house. There's the potential need to actually have to go out to eat if you can't actually cook that night for your kids. I know I've faced that. So just having reliable power is a huge benefit to customers. Now, how do they do this? This wasn't rocket science. The whole notion is you deploy within the grid automatic switches that will automatically open or close in order to go isolate and reduce the affected area of an outage. So say a tree brushing against a power line, or say a lightning strike knocking out a power transformer. You want to automatically and within seconds isolate that outage down to the smallest number of customers possible, and then you want to go ahead and roll the truck to that location as quickly as possible to then restore power. So the benefits I'm showing here are just actually the automatic reclosers doing their job in sectionalizing the outage, restoring power automatically to all the customers that aren't directly impacted by the fault. This doesn't cover the additional benefits of actually getting that truck there sooner and restoring the power sooner. That's covered in a separate use case, but those benefits are present as well. So these are all good, but in some ways, these are kind of softer benefits. You can imagine someone might not notice the reduction on their bill from the lower delivery rate. And the previous two are benefits that customers might not be able to quantify specifically. But here's one that can be quantified very specifically. So OG&E faced a challenge related to, ironically, the duck curve that we all heard about earlier today. So they had a late afternoon, early evening peak that would emerge as customers came home, turned on their air conditioning, started cooking, turned on the TV, and they were faced with a choice. And their choice was simply this: should they go spend $300 million to go build 2 gas turbine-powered peaker plants that would operate for cumulatively 10 days out of the year, or should they instead invest in deploying a smart grid to cover their entire population and then offering a time of use-based rate incentive coupled with some technology I'll talk about shortly to shift that demand out from being a peak then and out actually flatten that out and eliminate the need for building the peaker plants. So they took the bold move of saying, we want to go ahead and not invest in an asset that's going to be used highly infrequently. Instead, we actually want to spend those dollars on solving this problem. And oh, by the way, we think our customers will actually spend money. So they spent 2 summers, and we were actively involved with them in actually proving out the concept. And there were a few concerns. One of the first concerns was, will this only benefit high-income customers, right? What about the lower-income customers? Are they also going to receive any sort of benefit? And then the second concern they had is, well, how sticky was this going to be, right? Once they started rolling out the service, were they going to see kind of a one-time benefit, but over time, that benefit would go away? And they looked at a variety of technologies. They looked at a customer portal and delivering that through different means, whether that be the website or email or pages and text. They also looked at something called a smart thermostat. And it works remarkably similar to how a normal thermostat works, other than it has 2 additional features. The first feature is the thermostat displays the cost of energy at any point in time, so the customer knows exactly how much they're paying. And second, the thermostat can automatically receive these pricing signal information and adjust the set points by a couple of degrees when the price of power is highest. So they've rolled that program out. They rolled out the web portal to all their customers, but then they had an opt-in program for rolling out that smart thermostat and deploying that, and their goal was to get it to 20% of their customers. At the time this slide was created, they were at approximately 110,000 deployed. So the savings on average per customer for a residential customer were just over $150 per year, and then the savings per commercial customer were over $300 per year. So a gigantic success, again, opt-in program. And I heard reference earlier to something called shadow billing. So that's exactly what OG&E did, is they offered customers, said anyone who switches onto the time of use rate, for the first year, you will get billed the lower of whatever rate you're on, either your previous rate, which was a typical tiered rate structure, or time of use. You get to pay the lower of the 2, and then you can decide for the following year which program you want to be on. They invested heavily in communicating this out to their customer base, and the net result is they had extremely high satisfaction, and through the annual surveys that are done in utilities, they ended up being #1 within their peer group. So a very successful program directly attributed to that decision to invest in energy savings and choice for their customers and flexibility versus an asset that would be used infrequently. Now, as we're talking about energy awareness, I know this is something that I think Brian and his team at Maui Energy have found, is there's a direct correlation between knowledge on the part of the consumer and decisions they'll make to actually save energy. And I guess the example I love to give with this is, most of us have a gas-powered vehicle, and I'd be willing to bet that everyone in the audience knows exactly the price of gas relative to the different fuel stations that are close to their home or business, right? You know exactly that this gas station is always about 10 cents more, that one's about 4 cents less, and you probably even try to time your fill-ups to coincide with where you can go save just a few pennies per gallon. So I would argue that customers are quite smart and quite willing to go ahead and do that sort of math if they've got access to information. And the problem with their electric bills is usually they get the access to information well after they've consumed the electricity, and it's done in a measure, kilowatt hours, that few people actually understand. So translating that to dollars and cents, making that information available in real time, and what this chart shows is the more real time and the more tangible, the more granular you make that information to the consumer, the more energy savings that will result. And this study was done across a swath of utilities, not just our customers, but the findings were very consistent with what OG&E found from their program. Finally, I'll talk about distributed generation. And obviously, we've been talking a lot about PV and wind. This is actually an example different than the program that we undertook in partnership with Rick and his team at HNEI, where we focused on DG in the UK. And their challenge was actually similar conceptually. The time to get approval for deploying additional DG was just taking forever, and it was very costly to the utility to go do that. So the goal was, how could we dramatically speed up that time frame and dramatically reduce their cost of deploying additional distributed generation? And it was really all about getting access to real-time information. So they knew exactly how that distributed generation performed, so they would then understand the load on the grid, and they could adjust accordingly. So we were able to work with them to deliver the communications technology to solve that problem. You see the results. So in closing, I think a few key conclusions. So first off, hopefully some of you've seen from this and the specific savings I called out, these are all multiple applications. And if you choose the right smart grid technology, you enable multiple applications, and these benefits all pile up. Yes, maybe the AMI business case is right around neutral. Maybe it just barely pays for itself. Maybe it's slightly in the red. But if you can then deploy additional applications on top of that same platform, right? We heard a lot of discussion about platform in the session I chaired earlier, then those savings can pile on quite easily. Next, hopefully proof that these sort of networks and these platforms do exist today. So I would strongly encourage the decision makers to not settle for any solution, any platform that doesn't have a proven history of supporting multiple applications. And then finally, and I think of this as, I'll paraphrase former president, there should be no customer left behind. Every customer should be able to participate. That doesn't mean you have to do a full deployment everywhere, but you need to be able to do that and connect every single customer who wants to participate. And ultimately, it's just then a business or commercial decision as to how to effectively execute that deployment. But ultimately, every single customer who wants to participate needs to be able to participate, and I will tell you that that technology exists for them to participate. Thank you very much.